Good morning. Sorry I can't be there today. I have to go to my son's school for an activity of his. But I wanted to make a few announcements. First, you're going to take notes. I've pre-recorded them so that you won't have any questions, or if you do, we can go over them on Thursday. And then on the back board, if you could go to that tiny URL or scan that QR code, and as a personal favor, put in your name and email and the school's name and address. We're trying to get Jan Brett, who's a children's author, to come to the kindergarten here. So we need as many votes as possible. So if you can do that for me, that would be great. Okay, and then after the notes today, I've decided to give you an additional 15 minutes to complete your tests. I know some of you have looked up answers. I know some of you have discussed things because this is a surprise to you, and that's okay. What I would like you to do is make sure that you're completing your quiz in a different color pencil or pen, and I'll leave out colored pencils with Miss DeMar. So on to the notes. Good luck. On lessons 63 and 64. Here's lesson 63 first. So how would you find the integral of the tangent of x? I would recommend rewriting it first. If I rewrite this as sine over cosine, and I choose my u to be either cosine or sine, it's not going to work because I need the other one to be negative, right? So I'm going to write it as the negative. This way I can choose my u to be cosine of x, negative being a positive, so I haven't changed anything. When I take my derivative, I get the negative sine of x dx. So that allows me to rewrite this as a negative 1 over u du. And what would that equal? Negative natural log of the absolute value of u, this case being cosine of x. Okay, so that's your final answer there. Likewise, in example 1, we're going to try to rewrite it, but if I rewrite the secant as 1 over cosine, it really doesn't help me much. So I'm going to do something that you're going to cross your eyes at and tell me how the heck did you come up with that. And I'm going to say, I'm not going to expect you to come up with it because it is so obscure. Why is this not writing correctly? So I'm going to multiply this by 1, but I'm going to rewrite 1 as the secant of x plus the tangent of x. And you're right, I would not expect you to come up with something like this, so that's why I'm showing it to you. If I distribute this, I would get secant squared of x plus secant x tangent x all over secant x plus tangent x dx. And if I choose my u, what is going on with this today? If I choose my u to be secant x plus tangent x, then my du is going to be what? What's the derivative of the secant of x? So, right, so that's the secant x tangent x. And then the derivative of tangent is secant squared. And oh, look how nicely that works out. That's that top value here, right? So we have a perfect u substitution. So that means I have the integral of 1 over u du. Well, we certainly know that. So that gives me ln of the absolute value of u being secant of x plus tangent of x, plus c. So this is my final answer. If you notice, that is one of these integral trig functions shown below. The integral of secant of x is equal to the ln of the secant of x plus tangent of x plus c. Okay, so I'm not going to go ahead and prove all of these on the right-hand side, or even on the left-hand side. We know the first two already. That's our cosine with the negatives in the middle, right? But all of the other ones here, you do need to know, and I do recommend memorizing them. Otherwise, you're going to have to come up with some sort of crazy substitution like up here. Okay, so don't do that. Do what you're told to do and memorize. That being said, do what you're told to do. Those of you that responded to the formative answer that I asked you to email me and tell me how you felt in preparation for this test. If you did follow those instructions and you wrote to me and you sent me an email, then you have earned yourself some extra credit on this test. If you chose not to follow instructions and not to send in an email submittal of your formative grade, then you will not earn extra credit on this test. And technically, I could hold the retake against you because you have not completed your formative assessment, which is what I asked you to do. But more about that later. Anyway, moral of the story, do what you're asked. Okay, so let's keep going here. Example 2. I'm going to rewrite this 1 plus tangent squared of x as what? And in fact, I think what I'm going to do is zoom in for a minute and talk about this for 1 second. If I have sine squared plus cosine squared, we know that's equal to 1. What are those other two identities that nobody ever seems to remember? Well, if I rewrite this exact one that everybody does seem to remember, and if I do it twice, I'm going to show you two different ways of getting to that other trig identity. All you have to do is divide by sine squared of x on one and cosine squared of x on the other. So sine squared over sine squared is 1, cosine over sine is cotangent, and 1 over sine is secant. Nope, cosecant. Okay, so that's one of those identities that nobody ever remembers. And then the other one, if we divide everything by cosine squared of x, then I get tangent squared of x plus 1 is equal to secant squared of x. And there's the other trig identity property that nobody ever remembers. So maybe that will help you in deciding what you want to substitute here. So yes, we can see that 1 plus tangent squared of x is the same thing as secant squared of x. So if I rewrite this as secant squared of x, and I'm taking the square root of that, then I know it's just going to be the integral of the secant of x, which I now know because I proved it in the last example, or I've memorized my integral of trig functions, and I see that it's the natural log of secant of x plus tangent of x, and we're going from 0 to pi over 4. So if I plug in, I get natural log secant of pi over 4 minus or plus tangent of pi over 4 minus the natural log of secant of 0 plus tangent of 0. And that simplifies knowing your unit circle. And I'm going to emphasize this once more. You guys keep asking for extra credit. I'm going to give some sort of pop quiz along the way of knowing your unit circle and knowing your trig. And I guarantee you, I'm telling you right now, it's something that you should get 100 on, and yet at least one of you will fail because you're not going to know it. So study it now. God, I'm preaching a lot today. Anyway, all right, plug that into your calculator and you get 0.8814 approximately. Okay, and then the next example, it says find the average value of f of x equals tangent of x on the interval from 0 to pi over 4. And just as a reminder, average value 1 over b minus a times the integral from a to b of f of x dx. So in this case, it's going to be 1 over pi over 4 minus 0, the integral from 0 to pi over 4 of f of x, which is tangent of x dx. And we know the integral of the tangent from above. So 1 over pi over 4 is 4 over pi. And I have the negative ln of the cosine of pi over 4 plus, because minus a negative, ln of cosine of 0. And that is equal to 4 over pi. If you plug it into your calculator, you'll get these values. Do not round until the end. And you get 0.4412. Okay? So that is lesson 63. Lesson 64, which we're going to move into now, actually is not any sort of new material. It's all review. So let's get into it. So here we are, lesson 64. For the warm-up, it wants us to list f and its inverse, f inverse of x. So for f, that's my original function. They give us a domain, -4, 2, and 3. If I plug in -4 into my f of x, what do I get as my y? I get -7. For 2, I get 5. And for 3, I get 7. Why am I writing this all out? Because it makes it a lot easier when I have to write the inverse. The inverse is just switching your x and y, correct? So if I already have the coordinates, I can just swap them, y comma x, and I would get my inverse function. Okay, and we'll go over what this looks like graphically in a minute. So nothing new there. For the definition of the inverse of a function, if f and g are inverses, then the composite function of each other will also equal x. So f of g of x is the same as g of f of x is equal to x. All right, so in this case, if I'm going to find the inverse of this function, I need to take my g of x and plug it into my x here. And if I do that, I'm going to have f of g of x, which is equal to 2 times, here's my g of x, the cubed root of x plus 1 over 2, cubed minus 1. So if I'm cubing that, so which of the functions has an inverse function? Well, I could look at a graph of this. I'm just going to do a sketch, but you could put this into your calculator to see a more accurate view of what this looks like. Give me 1 second. Okay, so it's going to do something like this. Okay. Is it increasing over its entire domain? Yes, so f is increasing over its entire domain, meaning it's strictly monotonic. Therefore, it has an inverse. Okay, And to verify this, we could take the derivative, right? F prime of x, since we have the actual function, f prime of x is equal to 3x squared plus 1. And we know that that's going to be positive, is positive for all values of x. Therefore, we're proving it's strictly monotonic. So f is strictly monotonic, and it must have an inverse function. Okay? For part B, if you graph this, you get something that looks kind of like this, I would say. Okay. It's got, yeah. So if we look at this, it certainly fails our horizontal line test in 3 places. So F is not 1-to-1. 1-to-1 meaning for every x you get 1y, and for every 1y you get 1x. That is not the case. Therefore, it does not have an inverse. Okay? And you can also show it by writing out the actual points. We know f of -1 is equal to f of 0 is equal to 1. They're all equal to 1. Therefore, the function does not have an inverse. Guidelines for finding an inverse function: you could determine whether the function has an inverse by solving for x as a function of y, switching your x's and y's, and then when you solve for y again, you rewrite your y as your inverse function. So the domain of the inverse is going to be the range of f. Your x's become your y's and your y's become your x. You can prove this to be true, again, by saying f of g of x is equal to g of f of x is equal to x. Okay? So here in example 3, it says find the inverse of this. So let's go through these steps. So first, I'm going to rewrite my f as y. Then I'm going to switch my x and y. So x is equal to the square root of 2y minus 3. Now I need to solve for y. So I'm going to square each side. That gives me x squared is equal to 2y minus 3. And if I solve for y, I get x squared plus 3 over 2. And the last thing I need to do is rewrite my f as the inverse function. Okay? And that's it. Nothing new, just review of what you already know. All right, and let's do one last example. Show that the sine function f of x is equal to sine of x is not 1-to-1 on the real number line. Then show that from -pi/2 to pi/2 is the largest interval centered at the origin for which f is strictly monotonic. Hint, find the value of its derivative on the interval from -pi/2 to pi/2. So if I look at a graph of the sine function, I have this going on, right? So this is from pi, -pi to pi. This would be pi/2. I don't need to go further. I just want to show you what interval I'm talking about. So we're talking here. And the reason why we're restricted to this domain is because, again, if you look at this graph on the side, that's as far as I can go and still pass the vertical line test on the sine function. Or if you look at the original, that's as far as I can go and still pass the horizontal line test on f of x. Okay? So there's a lot of different ways of saying this. You could say f of x is not 1-to-1 because many different x values yield the same y value. And you can show it with values. Sine of 0 is equal to pi is equal to sine of pi. Okay? So you see that here, here, and here. Okay? And then you could also say, f is increasing. Remember, strictly monotonic. So it's increasing from negative pi over 2 to pi over 2. Because f prime of x is equal to the cosine of x, and that's the derivative, right? And its derivative is positive there, but only on that restricted domain. Okay? And then finally, you could say that the left and right endpoints correspond to relative extrema. Left and right endpoints correspond to relative extrema. So you can conclude that f is increasing on the interval, and that in any larger interval, the function is no longer going to be strictly monotonic. Will no longer be strictly monotonic. Okay? So again, all a review, but I'll go over any questions you have tomorrow. So good luck. Finish up your quiz now. Make sure you're writing in a different color pen or pencil. What I'd like you to do is take out that different color pen or pencil now, and when you get your paper, underline your name in that new color pencil or pen so that Mrs. DeMar knows exactly which color you're using. Thank you, and I will see you tomorrow. Oh, and great season, soccer boys, and congratulations to hockey.